So there is a good news now we have for loops in Blender. Keeping in line with the focus on procedural modeling, a new feature has been added into Blender, called Repeat Zone. It allows us to repeat a set of actions within geometry nodes, just like a simple for loop. So in this tutorial, today we'll discuss about this new feature, and discover how to use this. Let's say we have created a set of pillars like this, and we want to place a copy of this plant on top of each of these pillars. If we need to do it just once or twice, we can do it using a simple geometry node. The node setup will be probably something like this. We can create a copy of the vase using a transform node, and then join it with the original geometry with a join geometry node. If we connect it to the output, we'll get a copy of the vase on the second pillar. But if we have to repeat it for all other pillars, we have to do the same thing multiple times. This is not only very tedious, it can become unmanageable if there are too many pillars here. So this is exactly where this new functionality can be very helpful, which is called Repeat Zone. This box has got a repeat input and a repeat output node, and this is where we have to add the operations that we want to repeat. This is available for Blender version 4, which is not yet released, but you can download the alpha version and test all the functionality. So we have to move all these operations inside this repeat zone. And it has got a number of iterations, which controls how many times the action should be repeated. Once we move them inside the box, it will look like this. We are taking the original geometry into this repeat input, then we have our translate geometry and a join geometry, and this whole setup will be repeated multiple times. So if we increase this number of iterations, we'll get a copy of the vase on top of each pillar. Now this is how we can create a for loop within geometry nodes, but the problem is, we are translating the geometry by a fixed amount. So what if the pillars are not so organized, and what if they have different heights? Let's say we have a series of pillars like this, with random heights, and like before, we want to place a vase on each of them. If we use the same geometry node and increase the number of iterations, we'll discover that these copies are placed at completely wrong places, because they are simply using a linear increment. We need to take the actual heights of these pillars, and use it in the calculation to position the target objects. These pillars belong to a collection called Collection 2. So the change that we have to do here is, we need to bring this collection using a collection info node, and then we have to connect it to the repeat input. We need to also modify the logic here, in order to pick up each pillar from this collection, and place the copy of the vase just on its top. So once we make suitable changes here, we'll have a node set up like this. We are taking the collection info node as an input to this repeat zone, and the actual processing is done within a node group. So we can also repeat a group node if we want. Now here, if we increase this iteration count, we'll get the correct result. This time, each copy of the vase is placed in the correct position. Then there are two more interesting things here. You can see that the input fields of this repeat input are exactly same as the fields of this repeat output, because these output fields are going into these input fields at each iteration. So there is a cycle going here, and the fields on the input and the output should match exactly. If you add any new input field, the same will be added to the output as well. We can also rename a field. Let's say we give a new name to this field called index. Now the same change will take place in all the four places, in the input and output. And the second thing is, this index is working like a loop counter. We are increasing it by 1 at each iteration. This is required to pick up an item from this collection. And instead of using a fixed number for the iterations, we can also drive it by the item count of this collection. We need to use a domain size node for this, and we'll pick up the instances option here, and connect its output to this iteration count. So Blender will repeat these operations for the number of items that we have in this collection. This approach has another advantage. Let's say we add some more pillars into our scene like this. Now, if we move them into this pillar collection, we'll see that a vase is automatically added to the new pillars. The geometry node is repeating for each object of our collection. It's so easy. In our next example, we have the same set of random pillars, and we have a similar geometry node with a repeat zone. But instead of placing multiple copies of the vase, we are evaluating the pillars in a loop to get the tallest pillar, and we are moving the vase to that pillar. And the for loop is repeating for each object in this collection. So if we change the height of this tallest pillar, the vase will switch over to the next tallest one. It's completely dynamic. If we keep on changing the pillar heights, either manually or through another animation, the vase will keep on jumping to whichever is the tallest pillar at any given point in time. So that's all for today, and I think this will see a lot of interesting applications once it's fully rolled out. I hope you learned something new today. Thanks for watching our tutorials, and don't forget to subscribe to this channel.